Now we'll begin talking about quadratic functions. So our goal here today is to be able to sketch the graph of a quadratic function. So a quadratic function is actually written in a form like this. Actually, we'll do a little definition actually first. Uh, it is a function that can be written in the standard form. Here's what it looks like. Y equals ax squared plus bx plus c. We're going to be using that a and that b and that c quite a bit. So the a are always attached to the x squared, the b is going to be attached to the x, and the c it really doesn't have a variable by it. Now, one thing we may also want to write here, and I think we wrote this in a previous section, is that a cannot equal 0. For a parabola, I'm sorry, I think what we'll do is we'll draw a picture for this one. So, just really simply, and this doesn't have to be a big deal, but we'll do a coordinate plane. And we talk about a parabola. Here's what it is. Oops. We're going to keep write a parabola as the it's basically a U-shaped graph. Now I'm writing it like this. It doesn't always have to go like this. It could be a little different. Could turn upside down, or for example. But the way I'm going to write it looks like this. Okay. So that's good enough. It's a U-shaped graph of, and it really comes from these quadratic functions here. All right, our next thing is the vertex, and I think we're going to do this as a graph too. So go ahead and give yourself another coordinate graph, and I'll make mine here with black. So coordinate graph, and we'll make another little U-shaped graph. Might look something like this. Okay, now here's what the vertex is. It's going to be this thing right here, right where it bottoms out. Now sometimes it's going to be when it tops out too, but for right now we'll just use this as our example. It's right where it bottoms out on the U-shaped graph. And then finally we have an axis of symmetry. So for an axis of symmetry, here's what this looks like. It's going to be the coordinate plane again. And by the way, I'm writing this so you can save writing a bunch of words. Axis of symmetry might look something like this. I'm going to do an upside down parabola this time. So I'll do it kind of like this. Now, this thing right here, right in the middle, right there, where it divides this, it goes right through the vertex, as you can see, and it divides the parabola into two symmetrical parts. So there's one here and one here that looks like a mirror image. This thing right here is called the axis of symmetry. And then graphing a quadratic function has some rules, as a lot of algebra does. Here's something we can use. To find the x-coordinate of that thing that we call the vertex above, let's give a different color for this one. That x-coordinate of the vertex, here's what we use, and it always works like this. It's kind of nice. It's that x-coordinate is going to be the opposite or negative b over 2a. Now, where did the b and the 2a come from, or the b and the a? They come from back up here, right there, and right here. So that's where the b and the a come from. That's how we find the x part of it. Then when we make a table of values, including x values to the left and the right of the vertex, that's our next step. And the final thing we're going to be doing is we're going to be plotting the points and connecting them with the smooth curve to form a parabola. Now we'll do these for real on the next example.